Okay, rationals, so fractions. Okay, when you're doing this unit, it's a lot of factoring stuff. So we're going to look at each of the bottoms here, the denominators, and decide how to factor them. The first fraction I'm going to leave. The second fraction I'm going to GCF factor. And the third one I'm going to simple trinomial factor. Okay, so now I'm going to add. And so when I put adding fractions together, I need a common denominator that will fit everything in it. So I'm going to need an x plus 3. I'm going to need an x. And I'm going to need an x minus 1. So the first one fits in there. This 2 fits in there. And these 2 fit in there. Yep. It's good. It works. Okay, and then the process is you look at each and say, what did you change by? So this first fraction had the x plus 3. So we're going to change it by that and by that. So by an x and an x minus 1. The second fraction, it had that and that. So the change was x minus 1. The third fraction had, so the change to this one was the x. Okay? So common denominator, and then this is what did you do to each fraction, right? So now it's just algebra stuff. Can you do your math right? So remember there's 3 things going on, so multiply 2 of them. So if I do this, I get x squared minus x times 5 yet. So now I'm going to go 5x squared minus 5x. 5x squared minus 5x. Okay, please pay attention. Here's the common mistake. There's a subtract and it has to go into both. So minus 2x. And plus 2. I feel like that's where I catch people. Plus 4x. Okay, the last step is just simplifying, which means can you collect anything together? 5x squared. There's a bunch of x's to put together. So minus 7 plus 4 is minus 3x. Okay, multiplying and dividing fractions. So again, lots of factoring. So go ahead, factor everything you can. I see a difference of squares. I see GCFs. I see simple trinomials. Okay, know your strategies. Okay, when you are multiplying and dividing, you can look for any top-bottom cancellation. So top, bottom, top, bottom, top, bottom. Okay, do you understand you cannot cancel x there? That's not allowed because it's an adder.
When you cancel, it has to be like the exact same equation, like x subtract 2, x.
Yep. I had this mistake quite often in this unit. People trying to cancel something that looks like that, that's not the same. Okay? What do you do with something that looks like this?
Negative out.
That's a negative out. So I would rewrite that as a -1 out. And I like to write my x first. So if I take a negative out, my x is now positive. And if I take a negative out, my number is +5. And then there is no cancel. It's not the same thing. Okay? That negative out, that tricked a few people. And on an exam, what would you do if this was a division question?
Flip.
Flip, multiply. Same thing, but just one more step is the flip. Okay, solving equations, you have 2 ideas. They are cross multiply or common denominator drop. Those are your ideas. So what is the strategy to this one?
Common denominator.
Common denominator. And then this one is a cross multiply because it's 1 fraction equal 1 fraction. You can do that. Okay, so solving this equation with a common denominator, you have 1 fraction on each side, and you have to pick a denominator that would work for everything you see. Would you have picked 3x? Okay, I had another mistake of people picking something like 3x squared. Okay, yes. That is a common denominator, but it's not the smallest common denominator, which is going to probably cause you some math problems later because it's just going to get too complicated. So trying to pick the smallest one. Okay, here we go. What do you have to do to the first fraction? Times by 3, so 15. Looking at the second fraction, it got times on the bottom by x. And then over here, this one got times by 3. So we call it common denominator drop. So the conclusion is, if the bottoms are the same, this top has to equal that top. Okay, we also have to just do a side note here. What am I not allowed to have as a solution? There's something that's not possible as a solution. 0, because it would create something that's undefined here. Okay, so just be careful. Okay, here we go. Cross multiply we already picked. So one diagonal times equals the other diagonal times. Okay, that's it for strategy. The rest is just purely algebra stuff. Some distribution. Okay, what would you do with this? Algebra branch. Where would you go? That's where I would go, to the equal 0, because I see two variables. As soon as I see two variables, zero it out. Then I can try some of my factoring techniques.
Why is it always the opposite?
Why is which part always opposite? The answers? So you have to think here, what subtract 6 makes 0?
Oh,
Positive 6. Right? So it will always be the opposite, so that that number and the opposite number make 0 together. Yeah. That's what you're trying to do, make 0. Okay, let's just check, am I allowed to be these? What am I not allowed to have here, ever? -3 and -6 are not allowed as answers, so this is fine. Sometimes if all of a sudden you get something that's the same, you have to cross it off. Okay, this one is a chemical question. So if you have 10 liters right now of a chemical solution, so we have 10 liters and it's a solution. So right now, currently, there's some chemical and there's water in there. So if it's 3% strong, right, like that, 3%. So right now, there is 0.3 liters of chemical in there and a bunch of water. That's what's in it right now. So I'm going to write down, I'm starting with 0.3 of chemical, I'm starting with 10 fluid, and then I'm going to make it stronger by adding chemical, more chemical. So I add some chemical, but that chemical also adds to the fluid as well. So again, it's what's the chemical, what's the fluid. That's what's happening. And at the very end, I want to increase its strength to be 5%. So there's multiple ways you can write 5%. The easiest to remember is just whatever over 100. Because percent's always over 100. And I picked a fraction way instead of a decimal way because a fraction way allows me to cross multiply. Okay? I mean, you can obviously do it with a decimal as well. It's just that your math is maybe a little bit not as easy. Okay, so times, this is all isolation algebra, where you're just grouping things together, moving to one side, dividing. Okay, so I moved C's to one side, I moved numbers to the one side, divide, and your answer here should have some kind of units on it because it's the amount of chemical that you're adding, so give me a liters on that. Okay, we have 3 people raking leaves and they're doing it with times and rates. So here's my little strategy for these ones. I do a little chart. And then we talk about what's the difference between time and rate. Rate is always the time to do a job alone, the whole thing. So if James did the yard by himself, it would take 52 minutes. So that is a rate. Nick by himself, 58. Lisa by herself, 48. How long will it take if they are working together? And that's the same variable because when they work together and stop, that's all at the same time. Okay, so the fractions, James does x 52s of the job. And then the same thing. So these are the portions of the job each one does. And if you add up all of their portions, it would make one job, because, right? Okay, on this one, I know I'm usually preaching, get the lowest common denominator. Just get the common denominator on this one. It's okay to go big. This one actually might be really big. I just times them all together. Is that okay? Is that what you would have done too? Just times all 3 of them? So same bottom, and then did you notice how I already wrote that as a 1 like that?
It's a number.
Did you find a small one?
Yes.
Did you use prime factor trees, or you
No.
just guessed and checked?
I have a lowest common multiple button on my calculator.
Well, that's cheating.
I don't use it.
What is a number that's smaller?
18,096.
You can use it. I'm already committed to this one, but go with yours. I don't think I have that button on mine. Oh, wait.
It's just a button that says LCM. The second function.
I have a button, but I don't know how to use it.
Well, you put the first number, then the LCM, then the second number.
But you can't do it with 3. You have to do it
Well,
separately.
You can add a third one. Just hit the button again and put in the third number.
And like this. Whoop. Like that.
Yeah.
I learned something new today. It's so exciting. I don't like that. I'm cheating. I feel like I'm cheating.
Feels too easy.
Oh, yeah, that is. Okay. So on this one, since there's a 52 on the bottom, I would have to times it by a 58 and a 48. I'd have to times it by the others, right?
Can't you just do that without dividing?
Yes. You just did this divided by that, right? Yep.
These are big numbers.
Bless you. Okay, I'm dropping the denominators, right? Because I don't care about them anymore. If they're the same, the tops have to be the same. Ben, did we get the same answer with your number?
I just used that one.
Oh, thought you were gonna use yours. Do you remember when I said the prime factor tree to get your lowest common denominator?
Oh, I remember doing something
Remember
like
that? Remember all that? And then you like, what's in common? So 8 is their common divider, but then their multiple is now I have to times a bunch of the rest. But yeah. Okay. Last one. Time rate stuff again. Okay, so we have Johan and Sam working together to do an oil change. It takes them 20 minutes together. So that is them with their time. The time together. If Johan did it by himself, that would take 35 minutes. How long would it take Sam by herself? Okay, so Johan does 20/35 of that job. And Sam does 20x of the job. And then their portions together will make that job up. Okay, and then I pick a common denominator. So 35x. I figure out what I should multiply by. 35 needs to get multiplied by x, so the top x needs to get times by 35 there. Okay, then we call it common denominator drop for a reason. Bottoms is the same, conclude the tops are the same. So, does your answer make sense? Is always a question you're asking yourself. So Sam would take that long alone to do the job. Yep, makes sense. Okay, sometimes I get people who are giving me negative answers or something like that. That does not make sense. Do you remember your test? Some of you told me that the water is traveling 140 miles per hour. Probably not making sense.